Spencer was saying, so this is called a what we would call a vertical asymptote. Okay. So a vertical asymptote would be right in here someplace. All right, where those two lines bend. So anytime you have like a bending or curving action there, that's where you're going to have what we would call a vertical asymptote. All right. And the vertical asymptote we noticed occurred when or wherever that value is, right? So that is where our vertical asymptote is going to occur. Now, it sort of makes sense because if you are so let's say that I have 1 over x plus 2, right? So x, when x is negative 2, right, that's when I get 0. So x can't be negative 2 because if it is, it's going to be an undefined function. You can't have that. So then it would make sense that we would have this imaginary or vertical line there, and then our graph is going to come close to that, but never hit it because it can't. Okay, this would probably be a little bit more like this. All right, because it's undefined at that negative 2. All right, so wherever this value is down here is where that vertical asymptote is going to be. All right, so if we took, and another, well, let's do this first. So let me say that I have 1 over x minus 4, right? So then I would know, I cannot have 4, right? That's going to be an issue for me. So right here at 4, I'm going to have this vertical asymptote, and then this graph is going to do, and it's going to kind of bend away, all right, or bend up, but it's never going to touch it. It's going to bend, 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 all right, so it's never going to touch it. So what happens, and remember we were talking about limits? So if we take the limit of this as x approaches 4 from what we would say is the positive side. So this is the positive side, okay? This particular rational would go to positive infinity. But the limit as x approaches 4 from the negative side of f of x. So the negative side would be this side, so it's coming in from here. That's going to be negative infinity. All right, so they're bending away from each other, and that's a sure sign of having an asymptote at that vertical line there, wherever that number is on the bottom. So whatever you have on the bottom down here, so if I have x plus 3 and x minus 2, okay, then I can look at this and say, oh, wait, this means that I have a vertical asymptote. I'm just going to write that as VA at x equals negative 3 and x equals 2. Now, why can I say that x equals? Because you're not describing the function. You're describing where the vertical asymptotes are. So remember that question number 3, we talked about, hey, we could have, right, different numbers of asymptotes because we could have different pieces, right? We could have 3 pieces, we could have 2 pieces, we could have a horizontal line if we wanted to, right? That would give me a hole. But the whole idea here is this is where my vertical asymptotes are because I can't have 2 and I can't have negative 3 into that function. It's undefined. However, that's where my vertical asymptotes are. Again, because it never ever touches those numbers, it just gets close to them, right? It shoots way up or it shoots way down, right? There is a situation if I put an x minus 1 squared, all right, then we'll just go ahead and graph that. So type that in the Desmos, right, and you'll see what's happening there. All right, so go ahead and type that in, all right, and tell me what's happening as x approaches, let's do this. So tell me what's happening as x approaches 1 from the positive side, and what happens as x approaches 1 from the negative side. So in other words, what is it doing from both sides of that 1? So it's coming in from one direction, coming in from the other direction. What's the function doing? Okay, so you could chat that and throw it in there. Graph it up and chat it and tell me what you got. Yeah, one side is flipped over. So are they like increases on each side? Exactly. Exactly. Right? So it looks like this and it looks like this. So in other words, all right, here's my vertical asymptote, right? So this thing is kind of going like this and kind of going like this. All right, so it's increasing on both sides. A nice job, and I like the one side flipped upward. All right, so that's what's happening there. Okay, whereas the other one, right, one was going up, one was going down. This one's not the case. So the squaring causes that to happen. So it's kind of related to that whole double root thing we had. Remember when that thing would come down and touch the x-axis and bounce up? So it's kind of bouncing up on both sides. All right. So it's kind of the same way, right, with this rational, which is kind of interesting. But that's what's happening there. Okay. So right now we have, we have this whole idea of this vertical asymptote. Okay. And we know, by the way, but it's not in the book, right? If we have a rational function like this, and the top and the bottom, right, are the same, then we know that what we have is we have a hole, and that hole happens at -3. Okay. It looks like, I mean, I could graph it and say, oh, it's just a horizontal line. But in reality, if we go to that -3, okay, there's going to be a little hole there. All right, so if we go to -3 here, it's going to give you this, and all of a sudden, boom, it's going to be a hole, and it's going to go like that. So it is still discontinuous. All right. So that's our stuff on vertical asymptotes. All right. So now let's do this. So I'm going to put a couple here. I'm going to put some things in here. I'm going to have you graph. All right. I'm going to put them in here. So I want you to take a look at, let's do one like this. Let's go 3 divided by x plus 2. Okay. And I'm going to separate that and give you another one. Y equals parentheses x minus 1 over, x minus 1 divided by parentheses x minus 3. Gosh dang it, minus 3. Okay. I also want you to look at y equals 2x plus 4 in parentheses. And I'm putting these in the chat so you guys will get a chance to see them. X, let's go with a plus 1. Okay, and the last one I want to put in is y equals, I'm going to go with x, parentheses, x squared minus 1 over parentheses this, and go x plus 1. So I meant to put I did put in parentheses. Boom, there they are. So I want you to put those in the decimals. I wouldn't have them all going at the same time. All right. But graph them. Okay. And here's what we want to look for. What about the end behavior of these things? Okay. So I want you to graph them and think about the end behavior of those. So take a look at them, and we'll come together in a couple minutes and see if you can give me some ideas on end behavior of those. It's not very much. Okay, so I'm still good. All right. So let's take a look at. So what I'm going to do is stop this here for a second and come into here. Come on. Oh, here it is. And let's share this guy out. Okay. So let's look at this number 3 here, or number 1 here, and let's look at the end behavior. All right. How would we describe this end behavior? What's going on at the end? The end behavior is the same for the first 3. Ah, all right. I like it. So what is the end behavior then for number 1?
Is it positive or negative infinity?
Ah, so it's positive or negative infinity. Okay. Any other ideas? So when we think about end behavior, all right, we're looking at what is this thing approaching as far as the y value as x gets bigger or smaller, right? Because that's how end behavior is defined. So as the x gets larger, right? Okay, so as x gets larger way out here, all right, what is this y value getting close to? And what about on this end at the same thing? So as x gets very, very small, approaches negative infinity, what is this getting close to? Okay, so how would we say that?
As x approaches infinity or negative infinity, y approaches 0?
0. Okay, so y is getting very, very close to 0. All right, so in this case, this line has another bending action that it's getting very, very close to this x-axis, but doesn't ever get there. All right, so we call this a horizontal asymptote. All right, a horizontal asymptote. All right, I'm going to just stick with the horizontal part. So this is a horizontal asymptote. All right, so when we see this type of bending action or flattening out and leveling, then we say, oh, well, that's called a horizontal asymptote. And in this case, the horizontal asymptote was at 0, right? So let's continue by looking at this one. Okay, so what about this? Where is the horizontal asymptote on number 2? Now that we can use that, where is the horizontal asymptote on number 2? One. You're right. It's at 1 because this graph is flattening out in both directions and is approaching 1. Okay, it never gets to 1, but it's approaching 1. Okay, so we would say that the horizontal asymptote of this one here is 1. Okay, good. All right, sweet. So we got that. All right, let's go ahead and click off the blue one. Let's go on to the number 3. What about the horizontal asymptote of this one? We should be starting to feel pretty comfortable now. What about the horizontal asymptote of this one? 2. Okay, good. I looked away and came back and there was an answer. All right, 2. Okay, because again, this thing's just kind of flattening out and it's approaching 2. That's the end behavior. All right, sweet. So last but not least, I'm going to turn that off. Okay. Uh-oh. This is not very good. Oh, well, maybe it is. Oh, I see. Let me change this to a 2. And how to change it. There we go. So we change that to a 2. What about the end behavior of this one? Now remember, you're wanting to say, where is this going as x approaches positive infinity, right, and negative infinity? So, what is it doing? What's happening as it approaches positive infinity? What's it doing?
Y approaches infinity.
Y approaches infinity. What about if it approaches negative infinity?
Approaches negative infinity.
Right. So in this case, the end behavior is positive and negative infinity. All right. So this doesn't have a horizontal asymptote. But what it does have is what's called an oblique asymptote. Okay. So this one has what we call an oblique asymptote. Sometimes in certain textbooks, they call these slant asymptotes. Okay. But ours calls them oblique asymptotes. So here we had 0, here we had 1, here we had 2, and here we had oblique. So then you're I'm hoping that you're saying, how am I going to know when it's going to be 0? How am I going to know when it's going to be 1? How am I going to know when it's going to be 2? And how do I know when it's going to be oblique? Because that's the kind of thing you should be kind of asking. So let's go back and look at these. All right, I'm going to go and click this off. So if we go back to this one, okay, there's actually a couple of ways to figure out what the horizontal asymptote is, okay? One way is to look at this by the idea of a limit, all right? So if I take the limit of this as x approaches infinity, all right? And the way I would do that is I would take, and let me do this, but this is going to be like harder, so I'm going to stop this. So what I would do is just take this function, 3 over x plus 2, and I'm going to take the limit of that as x approaches infinity. Now you would say, how in the heck can you do that? Well, let's pick a large number, because I obviously can't put infinity in there. That wouldn't make any difference. But let's say I put 1,000,000 in here, okay? And I added 2. Well, that 2 really doesn't make a whole lot of difference in this whole thing. I mean, 1,000,000, and 2, there isn't a whole lot there as far as the difference between the two of them, right? It's just two things, but we're talking about 1,000,000 and 1,000,000 and 2. If I put 1,000,000 and 2 down here, all right, oops, then this guy's getting real close to 0, right? Because that number on the bottom is so big that, I mean, it's just right there at 0. Okay, if I put in decimals, it's probably going to say 0. All right. So that's one way you can tell, is by simply saying, I'm just going to put a super large number in and see what happens. Okay. The other way to tell is by looking at the degree. So you would look at the degree at the top, look at the degree on the bottom, and here's the rule. If the degree on the top, we'll say, is n, and let's say the degree on the bottom is m. If n is greater, or excuse me here, if n is less than m, then you're going to have 0 as a horizontal asymptote, okay, HA. So if this degree here is smaller than the degree here, we're going to have a horizontal asymptote at 0. So the degree of this one, now there's no x there, so that degree would be 0. This degree here, remember, is that power there, that's 1. Since 0 is smaller than 1, we're going to get a horizontal asymptote. Okay? So there's a couple different ways of looking at this. And I'm not going to ask you to know both of them, but I think you should know one of them, right? And you got to buy into the one that you understand. Okay? So if you understand the degree idea, run with it. If you understand the whole idea of the limit, run with it. You got to pick it. Okay. Let's look at the next one. So the next one has an x minus 1 over an x minus 3. All right. So again, I'm going to take the limit of this as x approaches positive infinity. So I can't really put in, right, infinity, but I can put in 1,000,000. All right, and I can put that in there and work this out. So I'm going to have 1,000,000 minus 1. You know, that 1,000,000 minus 1 isn't going to be a whole lot different. It's just going to be, you know, what, 5 9s, 6 9s, right? This on the bottom is going to be the same thing, except instead of having 6 9s, I'm going to have 5 9s and a 7, right? It's just not going to make a whole lot of difference. So really, I can just bypass those and say, hey, this is just going to be 1, okay? I'm going to have a horizontal asymptote at 1. And the same thing's going to hold with the degree, all right? So here, the degree of the top is 1, and the degree of the bottom is 1. So that means that the horizontal asymptote is going to be 1, okay? Now, there is a catch to that, and that catch comes in number 3, where we have 2x minus 4 over x plus 1. Okay? If we look at this from this point of view, we're now going to get 2,000,000, right? Because we're putting in 1,000,000 in for x minus 4, which is not going to make a whole lot of difference, over 1,000,000 plus 1. So these things are really not going to make much difference in the long scheme of things. Now look at this. So these zeros all go away, and we're left with 2. Okay? But the degrees are both the same, right? This is 1, and this is 1. So what happens there is that, yes, you get a horizontal asymptote, but this one's at 2 because you have a 2 over a 1. Okay? So it really comes down to what is the division of those two.
I don't really understand why you're crossing out the -4 and -1.
Who's asking? Just so I know.
Kendall.
Kendall, so here's the deal. So if I subtract 4, I'm going to get 1 with all these 9s and a 5. Okay. If I subtract 1, I'm going to get all these 9s and a 9. Okay. So you see, I mean, this here, the subtracting the 4 and subtracting the 1 really doesn't change the idea that this is still going to be just 2 over 1. Okay, I mean, if you divided those two things, you're going to get really, really, really close to 2. All right, it's just that the 4 and the 1, since the numbers are so large, they're just not very significant into that whole thing. Okay.
Okay.
All right. So you have to kind of be careful when you're looking at the degree thing. You have to look at that constant there and that number there, those coefficients, and say, hey, you know, if it's like, so for example, if we had 3x plus 4, right, over 2x minus 1, then our horizontal asymptote, forget these guys, is just going to be 3 over 2. Okay. So you kind of got to watch that. And that's because both these degrees are 1. So the last possible situation is, what happens when we have an x squared? Say we had -1 and I change this to an x plus 2. Okay. So here we're going to take the limit of this. Here, again, if I put that very large number, and remember, I could put anything I wanted in there. I could put 1 billion, right? Okay. But I'm not going to, but I could. Here again, that 1 and that 2 just aren't significantly going to have a big impact in on this thing. But this will. 1 million squared over 1 million? Wow. So that's kind of like having 2 squared over 2, which of course is just going to be 2, right? So that's what's going to happen here, is this is just going to be 1 million. Because that million is going to cancel out with that and leave me with 1 million on the top. Okay? So remember, in this case, the end behavior was positive and negative infinity. So when I have this situation here of 1 million over 1, it's going. I mean, it's just shooting, right? I could put 1 billion in there, I could put 1 trillion in there, and so forth, right? It's just going to keep on increasing. Same thing if I go in the negative direction, it's going to keep on decreasing. If we looked at the degree part of this, the degree here is 2 on the top, 1 on the bottom. So if n is larger than m, then that's where we're going to get our oblique asymptote. Okay. So there's a couple ways of looking at these things, and you kind of have to pick your way, all right, and what you want to do. All right. So what I want to do now is go through and say, okay, exactly what is it that I'm going to want you to know how to do on a test, because that's what you really want to know anyway, right? So let's do that. Okay, what is it that I'm going to ask you? So I'm going to give you some rationals, all right, and here's what I'm going to say. I want you to tell me what the domain is. Okay, I want to know about asymptotes. I want to know vertical asymptotes, I want to know horizontal asymptotes, and I want to know about oblique asymptotes. All right. I also want to know if there's any zeros of this thing. Does it have any zeros? What about that? Okay. Also, I don't think, sketching it is not a real big deal to me because obviously you can put it in decimals. But if you can sketch it without putting it in decimals, that's great. Okay. The other thing I'm going to say about this is, so I'm going to give you a bunch of examples and we'll go through and talk about it. And it's a good idea that you can do them without typing them in. But if you get in a situation and you're just not sure, just graph it. Okay? Just graph it and check it and see, oh, okay, now I understand. All right? So don't think that, oh, the only way I got to do this without decimals. No. If you get stuck, use it. All right? So these are the things. These are the things I'm going to look for. All right? Domain, asymptotes, zeros, and you can give me a sketch. But you can put it in decimals and sketch it. So I mean, it's not that crucial that we really do that part. So let's pick some out and let's go ahead and go through this. All right. So let's say here we go. F of x equals. Okay, I'm going to put an x over x minus 4. Right. So when you see this, here's the things, right? First thing I want to say is, what about the domain? Okay. What can you tell me right now about this domain?
X cannot equal 4.
Yep, x cannot equal 4. Okay. We cannot have 0 on the bottom there. Can't have it. So our domain cannot be 4. All right. Right away, you should be able to tell me then, here's what the vertical asymptote is. It's at x equals 4. Notice how they're at the same thing. Again, that's just because of what we talked about before we took our break. Okay, that's what happens. Okay, the function doesn't exist there. That's where your vertical is. Okay, all right. Horizontal. Any ideas on that? Look at the degrees. Think of the big numbers. Yeah, there you go. It's going to be 1. Right? The degree of this is 1. The degree of this is 1. They're equal. We're going to get 1. We don't have any numbers out in front here, so we're good to go. All right? 1,000,000 over 1,000,000, it's just going to be 1. That's our horizontal asymptote. All right? We have no oblique because it's horizontal. For zeros, I'm going to look at the top. I don't care about the bottom. I'm going to look at the top, and I'm going to see what would make that 0. Well, what's going to make that 0 is when x is 0. So I'm simply going to put down here that x is 0, and that's my zeros, okay? All right. You can put it in decimals and sketch it. If I had to take a guess at what it's going to look like, I would guess something like this. I know I'm going to have a dashed line there. My horizontal asymptote's at 1, so it's probably going to go like this, and it's probably going to go like this, except this 0 here, it has to cross at, so it has to cross, so it's going to be more like this. There we go. Okay. Yeah. That's what it's going to look like. Okay. So this is the stuff that I'm going to ask. Now your assignment's going to ask pretty much the same thing. Okay. But we'll take a look at some of those. All right, so let's do some more here. Let's go with x plus 1, x minus 3 over x minus 1, and we'll leave it. So let's say we have one like that, okay? Domain. Tell me about the domain.
X can't be 1.
X cannot be 1, okay? Can't have 0 down there. Oh, excuse me right now. Vertical asymptote. X is 1, right? Vertical asymptote, X is 1, okay? All right. Look, I got 2 of them done already, okay? Horizontal asymptote. Is there a horizontal asymptote in this situation?
1 still.
Oh, well, let's look at it. What's the degree of the top?
Would it be 2 actually?
Yeah, so the degree on the top is 2. What's the degree on the bottom?
1.
So does this have a horizontal?
No.
No. If the degree on the top is higher than the degree on the bottom, that means it's oblique. Okay? That means it's oblique. All right? Zeros. Look at the top, right? When's that going to be 0? So what would be my zeros in this case?
-1 or 3.
-1 and 3. All right? So that's how you're doing. That's what we're doing. All right? We're just going through these. Now, again, if you're looking at like, I don't know what's going on here too much, graph it. Okay? Just graph it. And it will tell you what you have. It will show you. Okay? 3 f of x equals 4 over x plus 2. All right, let's do this one here. So we have 4 over x plus 2. All right, domain. What's the deal there?
X can't be -2.
X cannot be -2, right? Again, bottom cannot be 0, okay? Remember I said that's the key thing? Denominator cannot be 0. Oh, hey, if I got my domain, I got my vertical asymptote right now. I got it. That's right there, okay? All right, let's talk about the horizontal. Does it have a horizontal or is this one oblique? Does it have a horizontal or is it oblique? What do we got here?
Should have a horizontal.
We're going to have a horizontal. Okay. Look at the degree. 0, 1. So, what's our horizontal according to our rule then? 0. Very good. Right? So you're going to have 0 because, again, the degree on the bottom is higher than the degree on the top. 4 over a million is going to be 0. Okay? 4 over a million is going to be 0. All right? One last one.
We didn't do the zeros for that one.
Oh, sorry, there aren't any. There's no X's on the top.
Oh, okay.
Okay. Oh, hang on here. I'm backing off of this one. Sorry. My bad. I want to switch these. There we go. So we have that. Okay. All right. So this one's written in a little different form. Okay. When you have it written in a form like this, it's always a good idea to try to factor it. Now the bottom's already factored, but the top one's not. So it's always a good idea to do that. Okay. In this case, I got to find some factors of -10. They're going to give me a 3. Well, I know these are going to be x's here. -10, I don't have many options. I have 10 and 1 and 2 and 5. 2 and 5 are the only thing that's going to give me close to 3. So now it's in factored form. Okay. When it's in factored form, it is sometimes easier to figure out what's going on. All right, so domain, here. Domain, vertical asymptote. What's my domain?
X can't be 1.
X can't be 1. Very good. What's my vertical asymptote?
1.
Exactly. See how they're related? It's really easy. Okay? Does this have a horizontal or an oblique?
Oblique.
Yep, good job. Now, I pulled this one in for a reason. We've said that they're oblique, but we never said, how do we find it? What if we want to find that oblique? Well, let's do this, okay? I'm going to take this thing, and I'm going to divide it. And I'm going to use synthetic division, okay? So 1, -3, -10, and I'm going to divide it by 1, okay? Just like I would have before, if that was an x minus 1, I'm going to divide it by 1, the opposite. 1, 1, -2, -2, -12. I don't get a 0 because it's not a factor, but I'm not interested in that. I'm interested in this, okay? Since this is a quadratic, it's just going to reduce down to a line. So it's going to be 1x minus 2, and the remainder is -12, but really I'm not interested in that. Here's what I want you to do. Go graph this. Okay, I don't care, you can graph it in this form, you can graph it in this form. Put that in the Desmos and graph it. Then graph this line and see what you notice there. So you're going to graph two things. You're going to graph the f of x in either form, it doesn't matter, and then this guy down here that we came up with. Okay, go punch those in Desmos and see what you get.
They fit like a puzzle piece.
Yeah. Yeah. So what does that x minus 2 represent?
The oblique asymptote.
Exactly. So that is your oblique asymptote. Okay. So when you divide the top and the bottom of those two things, it's going to give you your oblique asymptote. Okay. So I'm giving you that information, but on a test, I'm not going to ask you what the oblique asymptote is. All right. I'm only interested in that you can recognize that there is one. Okay. But you might see that on some of your stuff on your assignment. Okay. I'm going to stop this. All right. Because I have about 10 minutes. And I'm going to show you this stuff here. Oops. This is in section 3.5, okay? And I want to make sure you guys all understand this because every problem except for the last 3 that we do on this page, okay, has you do this right here, okay? Now, if I go back to 253, okay, it has you do about 4 or 5 different things. $253 wants you to factor the numerator and denominator, which I already said is a good idea, and find the domain. So that's no different than what I'm asking you. Write R lowest terms. Well, that's if things cancel out, but you know, they might not. Find and plot the intercepts. The only intercept that I'm interested in is the x-intercept. I could care less about the y-intercept. It's just not important, okay? Find the vertical asymptotes. That's the same thing that I've asked you to do. This says determine the behavior of the graph on either side of the asymptote. Don't worry about that. Find the horizontal or oblique. Again, that's what we've been doing, okay? And then it says plot points. Don't plot any points, okay? Use the zeros to divide that, and please don't do number 6, okay? Don't do number 6. That's a waste of time. So all you want to do on these is do exactly what I just did, showed you what was going to be on the test, right? So domain, asymptotes, zeros, okay? Don't do anything else. Just do those things, all right? Because that's what's going to prepare you for the test, okay? Doing all that other stuff is only going to add more aggravation and stuff. Just do what I said. Domain, x-intercepts, vertical, horizontal, oblique asymptotes. You can sketch a graph if you want. I'm not too, again, you can put that in decimals. That's why I don't think sketching is a big deal. So that's what those problems are going to be. All right. There's going to be some trickier ones. Some of these you're going to be able to factor. Some of them you aren't. But just follow those rules, right? Because you look at the bottoms are going to tell you what the domain is. It's going to tell you what your vertical asymptotes are. Okay? Don't waver away from those rules. All right? Look at the degree here, like on 34. Perfect example of this. Okay? Right here. Degrees are the same. Okay? So you know right now, we don't even care about this stuff. All I'm looking at is these. Okay? This is going to have a horizontal asymptote of 1. The degrees are the same. There's no numbers written in front of those things. Yeah, there's numbers written in front of these. These constants, though, they're not going to make up any big deal on this thing. Okay? If we put a large number in there, like a billion, that's going to be a billion squared. Subtracting 10 isn't going to make any difference. Okay? So that's why you don't pay attention to those. This one here. Again, the degrees are the same. But I have a 6 and I have a 2 there. So if I divide that, that means that my horizontal asymptote is going to be at 3 this time. Okay? So don't pay attention to these numbers. Only pay attention to those leading coefficients. All right? But just follow your rules. Okay? Don't get too worked up in some of this stuff. But if you do get worked up, you know, just graph them. Put them in Desmos and graph them and see what happens. Okay? 3.4 is easier. So, you know, those ones are going to be a little more straightforward. These ones here, you know, are going to be a little more challenging. But that's rationals. Okay? So, closing up here. Don't forget Monday. All right? Log on, do that quiz. I'll make another little announcement. Try this weekend to try to remind you of that. I'll get a review put up there, okay, on